In our previous class, I taught you how to carry out division of whole numbers without remainder, okay, without a last remainder. And I hope you were able to watch the video lessons and you understood the secrets, what you need in order to be able to carry out division of numbers. I also want to believe that you took your multiplication seriously, because an excellent knowledge of multiplication will help you whenever you have any problem to solve on division. In our class today, like I told you, we are going to deal with division involving whole numbers leaving a last remainder. So in this case, by the time we divide the last digit or the last part of our division of the numerator, we will get a last remainder. We'll still get a remainder where we will not have any other digit to attach it to. How do we handle such problems when dealing with division? So that's what I'll be teaching you in this video lesson. Now on the board here I have this short note. Now in the case where you are dealing with division involving whole numbers, leaving a last remainder, that last remainder can be expressed in two ways. One of the ways could be expressing that last remainder in fraction form. And in that case, that fraction form will be a proper fraction. Actually, the way we put the whole answer when we carry out that division is in mixed fraction form, okay? Because we'll get what we call the whole number. That's the whole number of times that the denominator divided the numerator. We call that the quotient or the whole number. Then we will get our last remainder. That last remainder can be written in fraction form, where you do that remainder, the last remainder, divided by the denominator, the divisor that you are using to carry out that division. So like I said, one of the ways in which we can express the last remainder is in fraction form. The whole fraction altogether is mixed fraction, but the remainder part on its own that you're expressing in fraction form is a proper fraction. Don't worry, when we solve questions you would see it clearly. Is that okay? Then another way in which we can express the last remainder is putting it in decimal form. Putting it in what? Decimal form. And these are the two different forms of expressing the last remainder which this video lesson class is based on. Talking about fraction form, how do you express the last remainder? Now I have this on the board, okay? You are giving numerator a number to be divided by the denominator. So I'm using n to represent the numerator which you are dividing by. I'm using d to represent the denominator. Now, if this division will give you a last remainder, the way you present your answer in fraction form is given as this: q, then r over d. This q is called the quotient. And the quotient, like I said, is simply the whole number of times that this denominator d divided the numerator. Then of course we have r, our remainder, as usual. From our last class, I hope that is already taken note of. Then divided by that same divisor. Now the way we read this part, this answer is q whole numbers, alright, r over d. This r is remainder over d. So maybe if I divided something and then the denominator divided the numerator 5 whole time, and the remainder maybe is 3. Are you getting it? I'm just assuming, and let's say what I used in divided is 4. So the way I will put my answer will be 5 whole number, alright, 3 over 4. Alright, our r still remains our remainder. And don't forget, how do we get our remainder? The fastest way of obtaining a remainder is knowing this remainder formula. The remainder is always what we divided in the numerator, so that n represents numerator, minus the quotient, which is the whole number of times the denominator divided that numerator, multiplied by the denominator itself, that's the divisor. I've used this formula before, in our last class when I taught you division of whole numbers without remainder. Now that I've explained this, I would like us to pick our very first question to see how we deal with division that gives us a last remainder. For you to understand this clearly, we are going to break this part into two different sections, okay? One would be a case where we express our answer in fraction form, that is in this form. Then of course we are also going to look at the second section. The second section will deal with writing our answer in decimal form. But the first section we're going to look at is writing our answer in fraction form, in this mixed fraction form. This question number 1 divides 7 by 2. So what I am looking forward to is getting my answer in fraction form. Solution. Alright, so I'm to divide 7 by 2, 7 over 2. So this would be equal to, let us find out. Now, our denominator is 2, the numerator is 7. So we need 2 times table to be able to solve this question. So if you go to 2 times table, you would see that 2 times 3 is equal to 6. Now we are dividing 7. So you need to go further and see. 2 times 4 is equal to 8. You can say that. Now 7 you are dividing in 2 times table is between 6 and 8. And from what you learned in the previous class, in the last class, you picked the smaller one. So we're going to pick that 6. 2 times what gave us 6? Correct. 2 times 3. It means if you do 7 divided by 2, because in 2 times table, 7 is not there exactly if you are multiplying. You cannot multiply 2 by any number to get 7. Therefore, you pick the smaller part, like I said, 6. And it is 2 times 3 that gives us 6. It means that 2 can divide 7 3 whole times. That's the quotient. So let us go. 7 divided by 2 will be 3 whole times. Let me write it. Are you following, right? Now, it is not exact division. Because from 2 times table, you won't see 7 there. You can't multiply 2 by any number to get 7. It means that 7 divided by 2, which is 3 whole times, will give us a remainder. And how do we get the remainder? Now you can usually do the calculation. If you cannot come up with the remainder quickly, you can show the calculation just somewhere beside your solving. Although the remainder here will be 1, but let's find out. I can do the remainder here, said, okay, remainder is equal to what I divided, which is 7, minus the whole number of times, which is 3, times the divisor, which is the denominator 2. Then if you do the bracket, 3 times 2, you get 6. 7 minus 6 will give you remainder to be equal to 1. So of course, the remainder here is what? 1. What do you do with the remainder? I will come over here and then write the remainder 1 this way. Then all over the denominator that I used in dividing, which is 2. And this is how we get the answer in fraction form. This is a mixed fraction. When I treat fraction, when I teach you fraction, you learn more about it. So this is simply my answer. Okay, the answer is 3 whole number 1 over 2 when you divide 7 by 2. If you look at the answer we got here, you see it's something like this. Q, which is our quotient, is 3. The remainder is 1. And of course, the denominator or divisor is still what we use in dividing, which is 2. So you see how simple it is. Once again, the knowledge of multiplication is really what you need to be fast in solving this. Let's pick our second question. Let us now solve these 2 questions we have, alright? If 72 is divided by 7, find A, the quotient, B, the remainder, C. Express your answer in the form Q whole number R over D. Then of course we have question 3. That question 3, the number is a bit big. Well, it doesn't matter. The secret, excellent knowledge of multiplication. And we are going to be guided by that as we solve this question. Already we've seen how we solved question number 1. That one was just quite simple because the number was so small, 7 divided by 2. Okay, let's go further and see what we do here. Solution to question number 2, we are dividing 72 by 7, after which we are to find these things given to us there. Solution to question number 2, we have 72 to be divided by 7. So let us see how we go about that. Are you ready? Now we have 2-digit number to be divided by this 1-digit number. So we are going to take them one after the other. We go to the first digit in the numerator, that is 7. So I'm going to do 7 divided by this 7. So let me cancel it out and see. 7 divided by 7. If you go to 7 times table, 7 times 1 is equal to 7. So 7 divided by 7 will give you 1. So I put down the 1 there. There is no remainder. It's going to be 1 exactly. So we'll move on to the second digit, 2. 2 divided by this 7. You see that you say 2 divided by 7, the denominator. If you want to mention the denominator first, you can say 7 divides 2, the numerator. Is that okay? So we have 2 divided by 7. If you are mentioning the numerator first, you use divided. But if you want to mention the denominator first, you say 7 divides, alright, the numerator. Okay, just take note of that. I'll be going by 2 divided by 7. Alright, 2 divided by 7, small number to be divided by big number. The answer is always 0 remainder, the small number. So I'm going to divide this 2. 2 divided by 7 is 0 times. And then of course our remainder will be that same 2. Let me write it here, remainder 2. But before I write it, let me ask. That remainder 2, is there any digits in the numerator that I have not divided? They gave me 72, you know, that's the question. I've divided 7, I've divided 2. And after this last division, I had remainder 2. Now I've divided this 72 given to me. There is no other digit for me to attach this my remainder to. Therefore, that remainder 2 is our last remainder. So I'll just put it somewhere here, remainder 2 is equal to 72 divided by 7, alright, is 10 whole number. 10 whole number. So I'll write that here. The remainder, which is our last remainder, is 2. So I'll put the 2 there to be divided by the denominator 7. You know, you don't need to divide this denominator 7. Don't go and divide 7 by 7 and get 1. Don't do that in this case. Reason, there is a last remainder. Are you following? We had a last remainder here. That remainder will still be there to be divided by the denominator. I'm saying this because in our previous class when I taught you division without remainder, by the time we finish our division, we always divide the denominator by itself to get 1 in the denominator. You don't do that in the case where you have your last remainder. Are you following? You still leave that denominator because, like I said, the denominator will still be there to divide that last remainder, which we write in this form. Now, I need you to know that this answer we got here, this part 2/7, is a proper fraction. Is what? A proper fraction, just like I told you in the introduction to this part of division. But this whole answer is mixed fraction. 10 whole number, 2/7. Please, let's move on to pick out the things we are asked to find. A, the quotient. We are asked to find the quotient. So I'll simply write, the quotient is 10. Of course, that is the whole number of times that the denominator divided the numerator, 72. Are you following, right? So we'll move on to B part. In the B part, we are asked to find the remainder. So I will write, the remainder is the numerator of that proper fraction in our answer. Of course, that's the last remainder, and it is 2. We are moving on to the C part of the question. In the C part of the question, we are asked to express our answer in the form Q, whole number, R over D. That is, write your answer in that form. And of course, I've already done it here. 10 whole number, 2/10. So I'm going to write Q whole number, R over D, simply equal to 10 whole number, 2/7. Good. I'm done solving this question. So you see that our R is 2, our D divisor is 7, our quotient, which is whole number of times, is 10. Okay, let's move on straight to the solution to question number 3. In question number 3, we have to evaluate 5,632 divided by 21. 5,632 divided by 21. This is quite a large number, and we need 21 times table. You may just be wondering, but I don't have 21 times table, at heart. I don't know it at heart. What do I do? Well, 21 is a two-digit number. That is why you learned place value method of solving multiplication. So you can actually arrange 21 and start multiplying by something to know or to be guided into what you should do. But it's simple. Let's go and say what we do. Alright, as usual, we'll take them digit by digit in the numerator, starting with this 5. 5 divided by 21. 5 divided by 21, a small number to be divided by a bigger number. Alright, the answer is 0, remainder, that small number. Of course, you know how to get a remainder already. What you divided, which in this case 5, minus the whole number of times what you are using to divide. I've given you the remainder formula since. Now, the remainder, which is 5, I am going to attach it to the next digit there, because we still have other digits we've not divided. Now we have 56 now. I'm going to divide 56 by 21. 56 divided by 21. So this will take us to 21 times table. Let us find out if 21 can divide 56 exactly or not. So we go. In 21 times table, if you work it out, this is why I always advise you. Don't play with your multiplication. Don't. In fact, the way you deal with multiplication, you should be as fast as the speed of light. Even though I know you cannot move up to the speed of light. Okay? Light covers like 300 million meters every 1 second. A distance of 300 million. Just in 1 second, light will travel that distance. Anyway, I'm telling you now that the way you think when you are dealing with multiplication, you should move as fast as that speed. But like I said, you can't move up to that, but you just need to be fast. Now, in 21 times table, 21 times 2 will give you 42. Then 21 times 3 will give you 63. This thing is simple. All you just have to do quickly, 21 times 2, 2 times 1 is 2, 2 times 2 is 4. 21 times 3, 3 times 1 is 3, 3 times 2 is 6. This is how I got it. Which is what you learned in part 3 of basic arithmetics when I taught you multiplication. So don't say, I don't know this multiplication table, I don't have it in my brain. You can work it out as fast as you can. Alright, I have shown you that 21 times 2 is 42. And 21 times 3 is 63. What we are dividing here is 56. We are dividing 56 by 21. That 56 is between 42 and 63 in 21 times table, as you can see. So 56 is not exactly in 21 times table. That is to tell you that 21 cannot divide 56 exactly. If it divides it, there will be a remainder. So what do we do as usual? Since 56 is between 42 and 63, we pick the smaller one. Is that not so? And that smaller one is 42. 21 times what gave you 42? You can see clearly 21 times 2. And since it's the small one we are picking, we can now say that 21 can divide 56. How many times? 2 whole times. But not exactly. There will be remainder. How do we get the remainder? Now I'm going to show you this time around how you get the remainder using that remainder formula. Remainder will be what I divided 56 minus the whole number of times the denominator I'm using to divide. So you see that, right? 56 minus open bracket 2, which is the whole number, the quotient, times the denominator you're using to divide. If you work this out, of course, 2 times 21, you finish with the bracket first. That is 42. 56 minus 42 will give you what? You have 56 minus 42. Of course, this will give you 14. So our remainder here is 14. I hope you understand this, right? So if you are good with your multiplication, you'll be very fast in solving this. There is nothing there. There is nothing. What will hold you back is if you are joking with your multiplication, like you don't take it seriously. That's what would make this difficult. That 14, is it our last remainder? No. 14 is not our last remainder because in the numerator we still have some digits we've not divided. We have 3, we have 2. So that 14, I'll come and attach it just in front of these 3. And that will make this 143. That 143, I will now divide it by 21. So let us do that and see. 143 divided by 21. All these things I'm doing here are rough works, okay? Rough works. And these are the things you need to do, you know, just in a rough space in your book, so as to help you get your answer. So I'm going to wipe this. We move on. We are looking at 143 divided by 21. Again, I'll be very fast in thinking about 21 times table. This is 143. So the first, 2 digits is 14. I will be guided by that first 2 digits to know the number I will multiply 21 by, to give me something close to this 143, or even exactly 143 if 143 exists in 21 times table. And so looking at this, I can quickly think of using 7 to multiply 21. 21 times 7 will give me 147. That 147 is greater than 143 already. So you need to reduce that multiplication. Let us check 21 times 6. 21 times 6 will give you 126. 21 times 6 will give you 126. So you see, 21 times 6, 126. 21 times 7, 147. And what we are dividing is 143. That 143 is between 126 and 147 in 21 times table. You can see that. So you pick the smaller one because 143 is not exactly in 21 times table. So you pick the smaller number in between which you saw that 143. And of course that smaller number is 6. It means that 143 divided by 21 will be 6 whole times, but not exactly, because that 6 times will give you 126. There will be a remainder. Are you following? And I've shown you how you get the remainder. The remainder here will be 143, okay, minus that 6 whole times what you used in multiplying, which if you work it out, you are going to get 143 minus 126. Are you seeing that right? This will give you the remainder. Okay, let us check. If you work 143 minus 126, your remainder will be 17. 17 will be your remainder. Good. You see what I'm doing here, right? How multiplication is helping me out. 143 divided by 21 is 6 times remainder 17. Again, let me ask you, this remainder, is it the last remainder? You are correct. It is not the last remainder because we still have another digit in the numerator that we have not divided. So that's 17. I'm going to attach it to this 2. Alright, just in front of the 2. And that gives me 172. This 172, I will now divide it by 21. I'll be fast now. If you work on 21 times table again, you will see that 172 divided by 21 will be 8 whole times. 8 whole times, but not exactly. There will still be remainder. That 8 whole times will give you 21 times 8, 168. 21 times 9 is 189, which is greater than what we are dividing 172 already. So we pick the smaller one. But if you work on 21 times table, this 172 will be between 21 times 8, which is 168, and 21 times 9, which is 189. So you pick the smaller one, which is 8 whole times, and then you go for your remainder. And how do we get to our remainder? The remainder will be what I divided, which is 172 minus 8 times 21. And 8 times 21 is 168. So I'll quickly do 172 minus 168 to get my remainder. And of course, the remainder will be 4. The remainder will be 4. Now I'm going to ask you this question. This remainder, is it the last remainder? This 4, is it the last remainder? And I will say yes to that. That 4 is the last remainder because we have divided all the digits in the numerator given to us. 5,632. We've divided every single digit there. So this remainder 4, there is no digit left in the numerator for us to attach it again. And therefore, that is the last remainder. So I'm going to write it here. Remainder 4. That 4 is the last remainder. I'm done with my division. I can now collect my answer and write it in mixed fraction form. This would be equal to, when 5,632 was divided by 21, it gave me 0268. I've told you already that this 0 is insignificant. It's not part of our answer here because there is no decimal point after this 0, so we'll forget about it. The 068 is actually 268. And that is the whole number of times that 21 divided 5,632. Are you following? So we have 268 whole number. The last remainder is 4. So it's going to be 4 over that denominator 21. I've told you, don't divide the denominator by itself where you have your last remainder. The last remainder will still be there to be divided by 21. Okay, let's conclude. We've gotten our answer already. Therefore, 5,632 divided by 21 is equal to 268 whole number 4 over 21. And of course, this is my answer. Very simple. Yes, it is very simple. What is holding you is one and only one thing, which is a good knowledge. No, I will not say good knowledge, an excellent knowledge of multiplication. Make sure you don't play or joke around with multiplication. Make sure you work on multiplication very well. Alright? At least, like I said, from 2 times table to 9 times table. Worst come to worst, to 9 times table. When I was working with this 21 times table, you took note that I used the idea of tens and units. So if I have 2-digit number or even more than 2-digit number, using it to divide, I'll just start arranging it, working it out using our tens and unit, that is place value, in order to be fast, to know the number of times that the denominator can divide anything in the numerator. Please, rewatch these solutions, especially that of number 3. We've solved 3 questions, writing our answer in mixed fraction form. Rewatch this video lesson, very important. If you have any question that the video lesson does not give an answer to, send your question across and you will get response you know already. You have to rewatch this video lesson again and again, because I am done teaching you division involving whole numbers, leaving the last remainder in a case where you are expected to write your last remainder in fraction form. That is to say, you put your answer in fraction form. And of course, our answers, as you've seen, are in mixed fraction. In our next class, I'll be teaching you how to write your answer in decimal form. But do you know what? For you to be able to write your answer in decimal form, you must get it in mixed fraction form first. Which means that this part of division is very important. Are you following? Without it, you cannot get your answer in decimal form. I hope I've communicated. That's good. Now, before I round off with this, I want to quickly point out something. Do you know, and you've seen clearly, that the numerator of the fraction in our answer is always the last remainder of the division? Look at it, like here it is 4. In this case, it is 2. Alright, when we did 72 divided by 7, the last remainder is 2. And that 2 is the numerator of our fraction. When we did 5,632 divided by 21, the last remainder is 4. And that 4 is the numerator of our fraction in our final answer. So I can give you some type of technical questions, alright? Questions that will make you be thinking, what do I do? But the answer will be very simple there looking at you. Pay attention, let me say this. It's a question. Given 268 whole number 4 over 21, what is the remainder when 5,632 is divided by 21? Is it that question? You don't need to punish yourself solving anything. The answer is just there in the question there. And the answer is the numerator of that fraction that I pronounced. 268 whole number 4 over 21. The answer is just that 4, that numerator. You see, the idea of that question is simple. I know if you divide 5,632 by 21, the answer you will get in mixed fraction is 268 whole number 4 over 21. So I just gave you that question. And so somebody that does not understand this will start punishing himself or herself solving. whereas the answer is just there looking at him or her. So the answer there is 4. Listen to this one again. Given 10 whole number 2/7, what is the remainder when 72 is divided by 7? And again, the remainder is the numerator of that fraction I pronounced. 10 whole number 2/7. The remainder is 2. So when you divide 72 by 7, your remainder will be 2. So in that question, the answer is already there. So take note in case you see such type of technical question. Of course, I'm going to include it in your quiz. I will see you in our next class when I teach you division involving whole numbers, leaving a last remainder where you are expected to write your answer in decimal. But like I said, make sure you understand this one very well because you need it to be able to change your answer to decimal.